Hello student, here in this lecture I will discuss about infrared spectra. Okay, how we interpret this spectra. Okay, and how we identify the sample by IR spectroscopy. Okay, and here in this lecture I will discuss the different types of application of IR spectroscopy. Okay, so let's start our discussion. In previous lectures of IR spectroscopy, I have discussed the principle of IR spectroscopy, the instrumentation of IR spectroscopy. Okay, the so basically, I give a small introduction of IR spectroscopy, the working principle of IR spectroscopy. Okay, so basically IR radiation for specifically meet IR radiation, which consists of different frequency of light. Okay, so IR radiation specifically specifically mid IR radiation, and this IR radiation consists of different types of frequency of light. Okay, so when this IR radiation fall on the sample, the molecule of the sample absorb specific frequency of IR radiation, not absorb the all of the frequency of IR radiation. They absorb molecule of the sample absorb specific frequency of IR radiation. Okay, depending on the absorption of molecule of the sample, it shows different types of stretching and bending vibration, which I have already discussed in previous lectures. Okay, the other frequencies, that means which are not absorbed by molecule, these frequencies are transmitted. Okay, and this transmitted light detected by the detector. Okay, and depending the detection of transmitted light, spectrum is formed and we analyze the sample. Okay, so this figure represent the spectrum of IR spectroscopy. That means we obtain this type of spectrum through detector of IR spectrometer. So see, in IR spectrum, x-axis represent wave number and y-axis represent transmittance. Okay, so in IR spectrum, x-axis represent wave number, y-axis represent transmittance. Okay, so see this spectrum here. You have seen two region. Okay, one is group frequency region, another is fingerprint region. Okay, so there are two region in IR spectrum. Okay, from 400 to 1600 per centimeter wave number region called group frequency region or functional group region. Okay, so from 400 to 1600 per centimeter, that means this region is called group frequency region or functional group region. In functional group region, we see individual and clear peak. Okay, so in functional group region we see individual and clear peak. And now see the fingerprint region. So in fingerprint region we see multiple peak. Okay, so first of all we see in which number in functional group region shows peak. Okay, which number means in which wave number functional group shows peak. Okay, so first we see in which wave number functional group region shows peak. Okay, shows peak. So first we see in which wave number functional group region shows peak. After that we match this data with reference list. Next we see fingerprint region. In fingerprint region we get multiple peak, but in this fingerprint region we cannot identify this peak individually because there are multiple peak. Okay, so we cannot identify the peak individually because this is very difficult task to us. Okay, but for a particular component it have specific fingerprint region. So for a particular component it have specific fingerprint region. So we take data from specific fingerprint region for a specific component and compare this data with spectrum library. Okay, and identify the molecule. Okay, so see, from fingerprint region we identify the molecule of the sample, and from functional group region we identify the functional group of the molecule of the sample. Okay, so here I have listed out some applications of IR spectroscopy. So see, infrared spectroscopy is widely used in industry as well as in research. Some of the major application of IR spectroscopy are: first is identification of functional group and structure elucidation. Okay, so how we identify the functional group? We have already discussed in this slide how we identify the functional group. So see here again. Entire IR region is divided into group frequency region, that means functional group region, and fingerprint region. Range of group frequency is 400 to 4000 to 1500 per centimeter, while that of fingerprint region is 1500 to 400 per centimeter. Okay, so in group frequency region the peaks corresponding to different functional groups can be observed. We have already discussed in this slide. Okay, so in group frequency region the peaks corresponding to different functional groups can be observed. According to corresponding peaks, functional group can be determined. Each atom of the molecule is connected by bond, and each bond requires different IR region. So characteristics peaks are observed. This region of IR spectrum is called as fingerprint region of the molecule, and it can be determined by characteristics peak. Okay. Now see the second application. Second application is identification of substances. IR spectroscopy is used to establish whether a given sample of an organic substance is identical with another or not. Okay, so IR spectroscopy is used to establish whether a given sample of an organic substance is identical with another or not. This is because large number of absorption band is observed in the IR spectra of organic molecules, and the probability that any two compound will produce identical spectra is almost zero. So if two compounds have identical IR spectra, then both of them must be samples of the same substance. Third application is studying the progress of the reaction. Progress of chemical reaction can be determined by examining the small portion of the reaction mixture withdrawn from time to time. The rate of disappearance of a characteristic absorption band of the reactant group and the rate of appearance of the characteristics absorption band of the product group due to formation of product is observed. Okay. So progress of chemical reaction can be determined by examining the small portion of the reaction mixture withdrawn from time to time. The rate of disappearance of a characteristic absorption band of the reactant group or the rate of appearance of the characteristic absorption band of the product group due to formation of product is observed. Now see the fourth application. Fourth application is detection of impurities. IR spectrum of the test sample to be determined is compared with the standard compound. So, IR spectrum of the test sample to be determined is compared with the standard compound. If any additional peaks are observed in the IR spectrum, then it is due to the impurities present in the compound. Okay. Next is qualitative analysis. So, see, the quantity of the substance can be determined either in pure form or as a mixture of two or more compounds. In this characteristics peak corresponding to the drug substance is chosen and log I0 by IT of peaks for standard and test sample is compared. This is called baseline technique to determine the quantity of the substance. Okay, so these these five are the applications of IR spectroscopy. There are so many applications of IR spectroscopy. Here I have discussed basically these 5 things. Okay, now these are the disadvantages of IR spectroscopy in quantitative analysis. Okay, so here I have given the disadvantages of IR spectroscopy. So today I stop here. Okay.